We are a curious species. We look up at the night sky and we wonder. For millennia, those glittering points of light were just that, lights. They were the domain of gods and myths, of poets and dreamers. But then, we built tools. We built telescopes to bring the heavens closer. And we built ships, not of wood and sail to cross oceans, but of metal and ambition to cross the vast, silent sea of space. One of the greatest of these ships is Voyager 2. Launched in 1977, it was a bottle tossed into the cosmic ocean, a testament to our insatiable need to know what lies beyond the next horizon. It was our silent emissary, sent on a grand tour of the giant planets. It used the gravity of one giant world to slingshot itself to the next. It flew past Jupiter, revealing volcanic moons and a storm larger than our entire planet. Imagine standing on a shore and trying to whisper to a friend on a boat so far away you can barely see it. Now imagine that boat is moving away from you at over 34,000 miles per hour, and the shore is our planet Earth. The distance is not a few miles, but billions. That's the scale of the challenge NASA faces every single day when communicating with Voyager 2. The probe's transmitter has about as much power as a refrigerator light bulb. By the time its signal travels across the solar system and reaches us, it is unimaginably faint. It is 20 billion times weaker than the power of a digital watch battery. We are, quite literally, listening for a whisper in a cosmic hurricane. To catch this ghostly whisper, we need very big ears. Enter the Deep Space Network, or DSN. This is a global network of giant radio antennas with facilities in California, Spain, and Australia. Their dish-like antennas are massive, some as wide as a football field. By placing them strategically around the globe, we ensure that as the Earth rotates, one of them can always be pointed toward Voyager 2. These antennas are the unsung heroes of space exploration. They are our lifeline to our robotic explorers, straining to capture the faintest of signals from the edge of the solar system and beyond. It happened on a Tuesday. The date was August 29, 2025. Deep within a control room at the Jet Propulsion Laboratory, data streamed in from the Deep Space Network. It was a routine day. The incoming signal from Voyager 2 was being logged, just as it had been for thousands of days before. The data packets arrived, faint but clear, carrying the latest health report from the distant probe. But as the system began to parse the stream of ones and zeros, something was wrong. Ones, zeros. The telemetry data, the part of the signal that tells us how the spacecraft is doing, was garbled. It was gibberish. This had happened before. A cosmic ray could flip a bit in the memory, causing a temporary glitch. Engineers began their standard diagnostic procedures. They checked the ground systems. They checked the antennas. They checked the software. Everything on Earth was working perfectly. The problem was not with our ability to listen. The problem was with what Voyager 2 was saying. The atmosphere at NASA's Jet Propulsion Laboratory shifted from routine monitoring to intense, urgent investigation. The initial assumption of a simple hardware glitch, a simple software glitch, began to erode with each passing day. The world's top experts in deep space communication were called in. They huddled in conference rooms, faces illuminated by the alien-like data stream. Whiteboards were filled with complex equations and diagrams, attempts to find a logical explanation for the anomaly. Was it a memory corruption? Had a high-energy cosmic ray done more than just flip a bit, but fundamentally rewrite a section of the probe's core programming? It was a plausible theory, but it didn't quite fit the data's strange coherence. There was a palpable tension in the air. These were people who had dedicated their lives to this mission. They knew the spacecraft intimately, like an old friend. What made the message from Voyager 2 so deeply frightening was not its randomness, but its complexity. A simple malfunction, a stuck bit, would produce a repeating simple error. A catastrophic failure would likely result in silence. But this was neither. The corrupted telemetry stream actually had a higher level of organization than the original functioning data it replaced. Data analysts ran the signal through every decryption and pattern recognition algorithm they had, and honestly, the results were baffling. The signal had characteristics of a language with repeating sequences and a syntax-like structure. It was as if the simple diagnostic sentences the probe was meant to speak had been replaced by complex, structured poetry in an unknown tongue. As news of the anomaly, carefully managed by NASA, began to leak to the wider scientific community and then the public, it sparked a firestorm of speculation and debate. The implications were staggering, regardless of the ultimate explanation. If it was a natural phenomenon we had never seen before, it meant that interstellar space contained forces that could reprogram our most advanced technology from a distance. This would fundamentally change our understanding of the galactic environment and the challenges of future interstellar travel. The universe, it seemed, was not just empty and cold, but potentially filled with unseen complexities that could interact with our technology in unpredictable ways. But it was the other possibility, the one that captured the public imagination, that truly changed everything. The idea that the signal was a product of intelligence that Voyager 2 had, in its silent journey, finally encountered someone else was a paradigm shift of Copernican proportions. For our entire history, we have defined ourselves as the sole thinkers on our world and likely in our cosmic neighborhood. The Voyager 2 signal did more than just present a technical mystery. It breathed new life into the oldest and most profound question we have ever asked. Are we alone? For centuries this question lived in philosophy and fiction. We populated the cosmos with our imaginations, gods, monsters, benevolent guides, terrifying invaders. The question remained hypothetical. The universe remained silent. The anomaly provided the first tantalizing piece of data. It moved the question from speculation into real possibility, a subtle but monumental shift in human consciousness. The signal forces us to confront the limits of our definitions of life and intelligence. We search for radio signals from Earth-like planets, assuming other intelligences follow a similar technological path. But what if they don't? What if intelligence isn't a biological organism? What if it doesn't use modulated radio waves? What if it manipulates the quantum state of matter directly? What happens next? The world holds its breath, waiting for the next transmission from the void. The team at NASA did send their command, a massive data packet designed to overwrite the corrupted system, restore Voyager 2 to its original state. Now all they can do is wait for the nearly 2-day echo to return. Will the probe respond with its familiar, comforting diagnostic language, or will the strange, structured message continue? A persistent and undeniable sign that something has fundamentally changed? If the spacecraft is restored, scientists will have a new, urgent mission to understand what happened. They will analyze every bit of data from the event. They will model the effects of cosmic rays, interstellar plasma, and even more exotic physics. The region of space Voyager 2 traversed will become the most scrutinized patch of emptiness in human history. Cryptographers, linguists, mathematicians, artificial intelligence experts, a project that would dwarf the scale of the Human Genome Project, a Rosetta Stone for a language not of this earth.